The plant floor is your profit center. Um, in the old days, everything was islands of automation. There was no interoperability. There was no communications, right? It was sneaker net, where you walked around with a clipboard and collected information. Now everything sits on hopefully one Ethernet platform network. There may be mixed protocols out there still, but everything's converging. We talk a lot about convergence onto one network. And so that network becomes more and more critical for protecting your business. And obviously the impact of productivity, downtime can be measured in thousands, tens of thousands, or even in some industries, hundreds of thousands of dollars per hour. So small amount of downtime can lead to severe cost issues related to manufacturing. And how quickly, when you do have a network issue, because all networks are going to have some sort of issue, right? We experience that at home all the time, rebooting routers and background noise or poor connections. So how do you diagnose that? How do you minimize your outages? And how do you respond to outages quickly are key aspects to understanding your network. So let's take a look. This is one of Panduit's favorite slides. It's our upside down triangle at the cost distribution of the network. Where do the costs sit within the network? And this is this varies obviously, but one of your highest cost items is software. Okay, and obviously with software, it's constantly being refreshed. You're renewing licenses, so the asset life is very short. But typically from a network cost standpoint, you're looking at about 60% of overall project budget with software. Networking equipment, and this data came from more of the enterprise data center world. So in the industrial world, we don't refresh our networking equipment as often as they do in the IT space, where they have a lot of service contracts and stuff, and they may be replacing servers every 3 to 4 years. So this may be a little weighted heavily towards the top of the triangle, but network equipment, typical asset life 5, maybe up to 10 years for industrial environments, but it's about 23% of your project cost, so a significant chunk of change. Next comes operations, and again, maybe 5 to 10 years and about 10% of your project cost for the network. And last is what Panduit loves to focus on. We are infrastructure experts, and the cabling and infrastructure aspect of any project is its smallest dollar component, about 7% of any typical project, but it also has the longest longevity at 20, 30, 40 years. If you do the network infrastructure backbone of the network correctly, that backbone can possibly survive the life of the building. Right, so it's very important to not neglect the infrastructure, the bottom of the triangle. 80% of network failures, and this is not a Panduit statistic, this is a SAGE research statistic, 80% of network failures happen in that yellow triangle in the cabling and infrastructure. When a network engineer or controls engineer has to go out and troubleshoot the network, diagnose an issue, it's typically, a ground loop, it's shielding, it's poor cable terminations, things like that. It's cabling issues. And also your ability to recover from a network issue and trace out issues, a lot has to do with how well the infrastructure is designed in. So when people are looking to cut costs, a lot of times they cut the costs at the bottom of that triangle. They don't do proper assessments and design of the infrastructure. They leave it up to the contractor to pull the media of his choice or to follow the pathways of his choice, or they don't design the physical layer. They do all the fuzzy graphics up top with the cloud charts and the Visio drawings, but they don't get down to the cabling schedules and all that stuff that's so important at the bottom of the triangle. So we love to emphasize that at Panduit. It is vitally important. Like I said, 80% of network failures occur down at that yellow portion. So investing properly in assessing and designing um, the physical layer is extremely important. Here's another study. This was by Aberdeen Group. I think it was about 5-6 years ago that they did this study. They measured industrial customers and they looked at their networks, and they basically ranked the top 20% of performance. They had performance metrics and like downtime and all that kind of stuff. You'll see them in a second. Excuse me. And then they ranked them in the top performing top 20%. And then they had the others, and then they had the laggards at the bottom 30%. But then they compared what are the top best in class doing differently than the other companies. And they found 4 main differences. And you'll see the first 2 are very, they're wide gaps, 30% or greater here. First, the best in class were building reliability into the physical layer of the network. So again, not a Panduit statistic. This came from Aberdeen Group, but they found that top performers were focused on the physical layer, like I just spoke about earlier on the previous slide. Also, they were building in data link reliability. Okay, so they were making sure the communication infrastructure that was going in could support the demand, the future growth. If you remember from the last presentation, I talked about how networks grow very organically over time. So whatever you put in today is not going to be what the network looks like in a few years. I think I brought up a case study for a wine company that we did the survey for. And if you recall, I said that they hired a company to go in and assess the network and document it. And about 3 or 6 months later, they said that information was no longer valid just because networks are changing all the time. You can also see, so besides data link reliability, also network management tools, okay? And there are lots of them out there. And there are lots of them that are IT based, and there are some of them, not as many, that are OT based. But the use of network management tools is vitally important to maintaining and troubleshooting a network. And then again, cable management wiring strategy aligned to network architectures. So that gets back to the standards, and we're also going to look at a common architecture that's used as well. So again, what did the best in class achieve that was different than others? Only 8 hours of downtime for the year, so 99.91% uptime, right? 11% reduced total cost of ownership, 90% OEE. And for any of you out there that are measuring OEE, 90% is very impressive. Okay, so OEE is a key statistic for manufacturers. And then greater than 25% operating margin contribution was achieved from those. So where do you start with a network? That's one of the things that people really struggle with, right? They just want to dive right into a specific little problem, and maybe they need to sometimes step back and really understand more about their network holistically. So first of all, you got to know what's out there, okay? I can't tell you how many times I've opened up a control panel and walk in the floor with a controls engineer, and he goes, "Oh, I didn't know that little Linksys router was thrown in here by somebody, right? Or I didn't know that was disabled or unplugged." So again, that's that organic growth of the network nature that I've spoken to several times. But network assessment and documentation, right? So learning what you have, and then also documenting that. The documentation is key. If you don't have documentation of your network today, put into your plans how to enable that, okay? Because if it's not documented, it's going to be very hard for you to migrate to the next generation. And then you need to create that migration plan, right? What are you looking to achieve, and how are you going to get there? I think that's pretty straightforward. And then also, once you do get there, how are you going to address maintenance and operations, okay? So how are you going to keep it up to date? How often are you going to do check its vital signs, right? Get out there, check performance, things like that. And then talking to leadership of your facility, what is the future plans, right? So if I were just to go design a network for Panduit right now, um, I I would not necessarily know what the leadership vision is for our manufacturing plant floor. I'd need to go talk to the VPs and understand where do they want to take the business, what facilities are going to be important in the future, where what's manufacturing going to look like for them, and what are their key business objectives. So when we talk about networks, planning and management, again, one of the biggest things we struggle with are legacy protocols and migrating from legacy protocols. So you can see from HMS industrial networks on the right, and we've actually had this graphic over the years, and we just refresh it as HMS refreshes it. And the blue area has grown every year, right? So the blue is your industrial Ethernet. The yellow is your more legacy field bus protocols, so things like DeviceNet, Modbus, CC-Link, Profibus. Green is an emerging area of wireless. For much of the early 2000s and into this past decade, even wireless was kind of a no-no on the plant floor. But networks are getting robust enough. Wireless is getting more reliable that we are actually seeing some wireless. A lot of that traffic is still not necessarily control traffic. It could be, asset management, access to the IT systems, things like that. But we are starting to see some controls migrate onto wireless. But you'll see the growth there. Ethernet is growing annually 20%, while the field buses are at a negative 5% growth. And that's to be expected as everybody migrates over to Ethernet. Talking to Rockwell, I think it was 2013, if my memory serves me correct, that they hit the threshold of products that they were selling. It was Ethernet devices overtook legacy network protocols, ControlNet and DeviceNet. So in 2013, they were selling more devices with RJ45 jacks on them than the legacy connectivity. So regardless, I think I beat that one to death, but you guys all know Ethernet is here to stay and is really the future. So, and you have to continuously refresh your network because of the software changes. The equipment is always getting smarter and better and requiring greater bandwidth. So as that network refreshes, again, if you can do the infrastructure today correctly, it can be sized adequately to survive multiple refreshes of network equipment. So where do you start from an architectural standpoint? How do you design a really robust Ethernet network? Well, at Rockwell, Panduit, and Cisco, we focus on what we call the converged plant-wide Ethernet model. So this is a truly tested and validated reference architecture. It's free for you guys to download out there. I think it's like 300 and something pages. It was started by Rockwell and Cisco over 10 years ago. And they created this architecture that they had been implementing. They took the best practices that they had been implementing in the field and combined it into one architecture. In our partnership with Rockwell and Cisco, we've always been, I've been doing CPWE presentations since the since about 2010, working with them. So we've been always aligned to this, but finally, about a little over 2 years ago, we actually were able to put a supplemental section to it that focuses on the physical layer. So the CPWE was very much logical in nature for most of its life, but now it has physical layer components as well. So if you ever sit through a Rockwell presentation, you've probably seen this slide dozens of times. This is, again, it's a 300-page document, right? So this is a really simplified single slide of it, but this is really your high-level view of the CPWE, the converged plant-wide architecture. And this is, again, this is your starting point for designing a highly reliable robust, future-ready network. And it takes into account association up to the enterprise there at layer 4 and layer 5, right? It has industrial demilitarized zone, which is basically your redundant firewalls. And that's important. One thing to note is you're going to see a lot of redundancy here. If you look, if you can see my cursor up here connected to the enterprise to the ASA firewalls, you'll see, you know, an A connection and a B connection, an A connection and a B connection. You see that crisscrossing of connectivity and then ether channel in between the switches or the servers or the devices. So here, the core switch. So everything has multiple connection points, right? So resiliency, reliability is built into this model. And by the way, how do we, why do we say this is validated? It's validated because not only is it from years of successful implementation, not prior to its writing, but also since it's been written, but also there's labs in Research Triangle Park in North Carolina, which is where Cisco is, their East Coast location. That's where their labs are. The Rockwell, I believe they're in, they do the testing in Cleveland, Ohio, and then Panduit in Tinley Park, Illinois. We all have labs that are just dedicated to putting this through its paces. So we have traffic generators. We have a device at Panduit that costs about as much as a Ferrari. That just puts a ton of demand on the network. And then we shape different, we plot out different configurations and we test it out with all different equipment, both Rockwell and non-Rockwell. We try to trip it up as much as possible, and then we compare it to what they're doing at Cisco and what they're doing at Rockwell. So this is constantly being validated and tested for emerging technologies. A good example of changes recently is you can see the wireless down here. These little blue connections down at the cell area zone. So those were added in the last couple of years. Anyway. One last thing I want to really point out to you is once you're below the industrial demilitarized zone, you're in the industrial zone, which is layers 0 through 3. And that's where your industrial traffic sits. And that's where you're running, typically for Rockwell solutions, at least you're running Ethernet IP and what's called SIP, Common Industrial Protocol. And the idea is SIP stays home, that Common Industrial Protocol. And I want to bring up Common Industrial Protocol here because it touches on some of the emerging technologies that we'll talk about. That is how we can, that's how you can do things like motion and highly synchronized events on the plant floor. So there's SIP motion, there's SIP sync, which is their timing protocol. There's also SIP safety. All right, so there's lots of common industrial protocols that play into the industrial Ethernet protocol overall that sits down here on the plant floor. When you get through the firewalls and up to the enterprise, you're back to your standard TCP IP, small p, small I, small p, you know, Ethernet that we're using right now for our Zoom connection. So anyway, SIP stays home down at the plant floor. That's kind of one of the rules. I talked about maintenance and operations and reducing mean time to repair. I did a cybersecurity presentation up in New England a couple years ago for water wastewater, which is one of the Homeland Security critical infrastructures. And we were talking about, you know, how do you troubleshoot a network effectively, make sure that you know what's out on your network. And one guy afterwards came up and told me, he said, you were spot on with a lot of the aspects. And he said, I had a down incident, you know, downtime incident where he had to find an issue, and it took him 2 weeks to trace the cables and find that exact location where the network was failing because it was intermittent. So he was struggling 2 weeks with a fluke tester out there testing the network and isolating the issue. That is exactly where network management tools can come into play. Not an advertisement for Panduit. Panduit does have one, but there are lots of good ones out there. Rockwell has one as well. There's lots of IT ones. You may have heard of something called SolarWinds out there. That's a very common IT platform for network management, but these are tools that will go out and basically crawl the network and discover all the devices on the network, and then we'll monitor the status of those devices, right? So you can see the screenshot is actually Panduit's. So in the center, we have a scanner, a computer, a server that has the software, and then it goes in and starts pinging all the devices and then understanding the association of the devices. And then the color coding tells you its status, you know, is SNMP enabled? Has it fallen off of the network and come back on, or has it completely disappeared off of the network? Or is there a new device plugged to the network? So this is something that works 24/7 for you. And these are kinds of things that a network management software can do for you. So it can do automatic topology mapping. So your documentation never gets out of date, like I talked about with the winery, right? They are vendor neutral, right? So regardless of device out there, it doesn't promote one device over other. It just monitors what's connected to the network. So you can monitor VoIP phones or static switches or PowerFlex drives or Indris-Hauser flow meters, right? Live health monitoring for the field devices. It goes all the way to the edge. It logs everything. And all these softwares do this, by the way. But you can get an event log. One of the things we do with ours, we tell people that buy the Panduit version, you know, every morning, hit the button, print out the event log, and give it to your maintenance guy, and it'll rate the top 5 issues that we're seeing in the last 30 days for the network, right? So anyway, you get the idea. You can see the other stuff there, KPI measurements. So this is really what helps get that OEE number and maintains it at that 90% or above threshold. Because I know if there was a network issue, I can just look at that software and it'll tell me, you know, this device had a bandwidth issue at 3 a.m. last night. And then I know, you know, to go check and figure out what's going on at that device or at that portion of the network. Also continuing education. You know, that's what we're doing here today. So we're doing this right now, but staying abreast of all the activities in the standards bodies, whether it's TIA, whether it's Cisco certifications like CCNA or CCENT for enterprise, or BICSI certification. That's one you may or may not have heard of in the past, but all of my counterparts, I'm actually not even on the network side. I used to be. That's why I'm talking. I can talk to this. I was on it 2 years ago, but all my counterparts on the network side of the business are RCDD, which is a BICSI certification for network design. So there's lots of standards bodies to follow along with, lots of classes to be taken, lots of certifications that you can get to be experts in the network. And if you want to learn more about this, this quick slide here, feel free to reach out to Mike or Lou or myself directly, and I can definitely get you guys a lot of good information of where to take your education to the next level. Okay, so let's talk about life cycle here. 4 main pillars to the life cycle. We talked about assessing the network. You're not going to know how to migrate the network to be reliable and future ready unless you know what you have today. And so doing that assessment and that documentation, that's where, again, that network monitoring software comes into play, because you can't be doing this assessment over and over on your own. It becomes too cumbersome. So having that software monitor is critical. Doing proper design work, again, leveraging From Electric and their design ability, leveraging Panduit, our design ability, or leveraging other vendors out there and their design ability. Or if you have that capability in-house, maybe you do, but proper network design, following the reference architectures, taking that structured approach is going to pay dividends. The reference architectures are meant to scale, right? So it's kind of a rinse and repeat. We call it a zone topology, where you create zones of the network. What that does is it helps isolate stuff, but it also helps you kind of like a rubber stamp. You can create a new zone, and then the backbone, you can tie in these zones. And then you can also troubleshoot and isolate issues down to particular zones. So following zone architectures and the converged plant-wide Ethernet is important. Deployment, obviously hiring the right contractor to do the terminations, right? There's a wide range out there. Panduit and our competition, we all certify contractors, okay? So whether you're using Panduit connectivity or another vendor's connectivity, reach out to whoever your connectivity partner is and ask them, you know, who's their contractors in the area? Who do they have certified? We make our contractors go through a preliminary onboarding and then every 2-year maintenance. So they have to do terminations and get them tested by us, and we teach them the latest and greatest changes. So constant having a reliable contractor to work with is important. And then obviously maintaining the network. If you set it up and just forget about it, it's going to go stale on you, and it's going to have that organic growth that's going to become unmaintainable. And it's not a matter of if, it's a matter of when it's going to bite you in the butt. So, okay. Any questions so far, Mike? Because now we're going to get into a couple of those future technology slides.
No, Jason, we don't have any at this time.
Okay, great. So like I said, these are all in different stages of maturity. Probably like Power over Ethernet. Power over Ethernet's been around since the early 2000s. Yes, it has. But it was just, there are too many build outs on these slides, sorry. Power over Ethernet, the latest standard, the 802.3bt, was just ratified in 2018, right? So it has been maturing over time. And Power over Ethernet is an awesome, awesome technology. Basically, we're delivering power, DC power, across the same cable as the data link, right? The Ethernet cable. So I'm sure everybody here is familiar with Power over Ethernet. That's how you connect your VoIP phones, and that's really where it started, is voice over IP. And in the early 2000s, we were delivering 13 watts. If you look at the little table in the bottom right, PoE AF 802.3 AF, the standard PoE is a 13 watt delivered to the end device. You'll see what are the two numbers. The top number is the injected power from the source, typically a switch that's enabled with PoE, excuse me. And then the delivered power is the 13 watts there. So that's your standard PoE. And then, you know, a few years later, they released PoE Plus, which is basically a little less than 30 watts delivered, a little more than almost 26 watts to the end device. What does that mean? Well, you can do a little bit more, right? So you can start hooking up IP cameras right there, static IP cameras, right? Then Cisco actually pioneered a 60 watt. They called it UPoE for a while, and that was really the first entrance into Power over Ethernet lighting. That eventually migrated into the standards bodies and became this 4 PPoE standard at 60 watt, 51 delivered. But you know, in 2018, PoE++, which is 100 watt technology, 71 at the end device, ratified. And so now we can do pan tilt zoom cameras, we can do badge readers, we can do door locks, we can do lighting, and we can get very fancy with the lighting, obviously, because we've got data going there and we've got power. So we can turn off lights and turn on lights based off of sensors and all kinds of things that I'm sure you guys have, as IFMA, I'm sure you guys are all aware of the cool technologies and all the changes in lighting. What I will say from an infrastructure standpoint is when you deliver power over Ethernet, you've got heat. And so the IEEE requires, doesn't require, you can do PoE on Cat 5e, but they recommend Cat 6a cabling for PoE. And really that's because of the heat rise and the ability for Cat 6a to dissipate the heat. When you're doing a lighting project or something, you're going to have bundles of PoE cables, and that center, the cables in the center are going to heat up pretty hot relative to the performance, and that can degrade performance. So we actually have white papers on how to build this out properly, and I think there's a link at the end. But PoE from an industrial standpoint is really now just hitting its strides for the plant floor. We're not really seeing a ton of endpoint devices yet, but again, wireless access points, and there are some devices that are starting to see that. I think, Lou, correct me if I'm wrong, but I think some of the newer Stratic switches support PoE as well. So you're starting to see industrial switches with PoE enablement.
Correct. Yes.
Yeah. So that technology is pretty mature, and I think a lot of people are familiar with it. What's going to be new to you, unless you went to Automation Fair last year, is single pair Ethernet. And this is this is probably the highlight of the new technology for you today. What is single pair Ethernet? This was just ratified in IEEE standards. Panduit's actually been a pioneer of it. One of Bob Voss, who's in our R&D group, is the chair of the task committee. And okay, so what is it? It delivers Ethernet up to 1 kilometer over a single pair, right? So when you think of copper cable for Ethernet, we're typically limited to 100-meter length, and we typically have 8-wire or 4-pair. So now we're delivering Ethernet over up to 1 kilometer. So where is it needed? Well, this has got a lot of interest. So automotive has it's got a big play there because of the lower weight of these cables with only a single pair in there. And so on vehicle applications are, Ford, GM, all those guys, Volvo, they're all over this technology. Industrial, a lot of times 100 meters is too limiting for us. Think big process plants or edge of the network applications. So the ability to get out much further onto the network with copper is very, very appealing to industrials. But digital buildings, again, the stretch that you have with this technology is very interesting. So the technology for the connectivity has just been ratified. If you're familiar with fiber optics, there's now a typical there's lots of fiber optic connectors, but the modern one that everybody standardizes is called an LC, a small form factor Larry Charlie LC connector. We're using that same basic body type, but we're having the copper connectivity within it. So it's a copper LC if you want for your IP20 rated applications. And then we also have, I believe it's an M8, it might be an M12. I think it's an M8 connector for the IP67 style. This is just being released. Panduit's actually going to have a minimal viable offering at the end of the year. So, like I said, it was just ratified in February. Sounds too good to be true. There is a gotcha. Okay, so by getting to 1,000 meters, we are limited in speeds. So this is not a high performance Ethernet backbone cabling. This is edge of the device, 10 megabits per second. Okay, so that's the limitation. But you can do bus style, or you can do point-to-point connectivity with this. And there's one more cool thing about it. You can deliver power over this as well. So you can power the edge devices over single pair Ethernet. It's like PoE, but it's called Poodle. It's power over device link. And anyway, if you want to learn more about it, again, the chair to the task group is within Panduit. So I've got the foremost expert on speed dial if you need to learn more about it. And we have lots of interesting papers and stuff around single pair Ethernet as well. But that's coming out this year. The next two are more food for thought, future looking technologies. So the first one is time sensitive network. Time sensitive networks really came actually out of the AV field. And this used to be called AVB, audio visual bridging. And what is it? Well, Ethernet by its very nature is not deterministic. And deterministic means that packets arrive on time when they're scheduled. That's why for industrial applications, we have to have the common industrial protocol, that SIP protocol I was talking about earlier, to create SIP motion so that, we're driving that motor on time every time to the exact point that we need it. And the way we coordinate all the activity on the plant floor is called SIP sync, which is a timing protocol, time synchronization protocol. However, until TSN came around, all these protocols, including SIP sync and other technologies out there for time synchronization, were best effort. Okay, they were pretty reliable. You know, obviously, we're doing some pretty cool things on plant floors with it, but they still are best effort protocols. TSN actually guarantees determinism and can be applied to standard Ethernet as well. So that's the big thing. So you can do scheduling and traffic shaping, as you can see here. You can do frame um, uh, um, preemption. That's the word I'm looking for. Kind of like quality of service kind of stuff. How this came out of audiovisual world, think of big stadiums where you have your speaker systems, and you know, if you're sitting in section 200 and the guy in section 215, and you know, you have all these speakers blaring. You used to get all those echoes and those time shift issues from the speakers playing the audio at slightly different times. So that's why when you go to large settings now, you can get perfect, crisp, synchronized, everybody's hearing the same thing at the exact same time type of signal, and that's from TSN networks. So again, automotive's interested in this, but has some play in industrials. Okay, so it's all about, oh, uh, I was going to talk about the physical infrastructure with this. So it is very beneficial for lower speed networks. It helps with that, but you do need to design for this. If you put in a robust network now, again, it will help support time-sensitive networking protocols in the future. So, oh, I'm sorry. I lost my train of thought there for a second. I wanted to relate it to the physical layer, and I just saw my note there on it. What's important, what really helps enable time-sensitive networks is higher speed networks. That's what I want to get to. So that's where it's not so much a bandwidth issue, but the higher the speed of the network, the better the TSN enablement will be in the future. And again, this is available now, but it hasn't been widely adopted except for in some spaces. But you're starting to see some industrial engineers take another look at this as a path forward for some applications. The last one I want to tell you about, let me build out this slide for you, is software-defined networks. And this is even more into the future, kind of fluffy cloud kind of conceptual stuff. This is really being driven from the data center world, but again, really catching the eye of people like Cisco and others for, for plant floor applications. So software-defined network is basically the ability to take some of the network aspects out of the hardware and put it onto the server. Okay, and if you're familiar with if then that, like logic statements like if this then do that kind of logic, that's kind of what this is promoting. And in fact, you can even download an app called IFTTT for creating things on your phone, logic statements on your phone. But what this does is it allows you to take and really manipulate the network to do specific tasks based off of things happening on the network. So let's say you have like the robotic welding expertise, and you talk to that engineer, that robot engineer, and he says, well, I'd really love it if the network could do this when this happens, right? And you can start to program that into the software-defined network. Another thing it does is it actually lets you do some white boxing because you can actually use some of the same equipment over and over within the facility. So you can get a switch, and you don't necessarily need specific requirements of that switch here that are different from switch requirements that are over here. You can kind of have the hardware be more uniform, and you can do a lot of those changes in a software-defined arena. So again, really future out there. I mean, probably talking decades before you really see software-defined networking. But again, planning for this type of skill set on the plant floor as it comes out of the labs and into actual product and technology and starts to be implemented in the field. Again, putting in that physical layer today is going to enable these kinds of technologies. So if you put in the proper fiber optic backbone today, we'll be able to easily migrate equipment here. You won't have to rip and replace in the future. That brings me to the last slide. So again, tons of resources. Here are some. So if you want information on the converged plant-wide Ethernet, there's the link. You can also just Google it. Rockwell and Cisco also have it on their websites. Tons of white papers. So that's actually just the landing page for our white papers, industrial white papers. And then, of course, case studies. You can see it's panduit.com/industrial case studies. Popular configuration drawings. I want to point these out. I love these things. And this is a concept I will point to Rockwell. We kind of stole the idea from Rockwell. They've done PCDs for a long time, and we just started adopting.
Jason, don't make that public on this.
What, that we stole it?
Yeah.
I think with permission.
You.
I think with permission.
Okay. Yes, it's the old SWIPE acronym: steal with integrity, pride
integrity. Exactly. So with their permission, we followed. So this design right here, you can kind of see. I wish I could zoom in, but go to the PCD site. I think there's about 20 of them, and it shows you how to take that logical framework of this converged plant-wide Ethernet and do it in a physical manner. And it actually, if you flip over the page, if there's a page 2, it actually gives you part numbers. So it calls out exactly what you need to deploy the CPWE. If you're doing a ring, if you're doing a switch level network, if you're doing a process network, if you're building out a micro data center, has these reference architectures that have been boiled down into popular configuration drawings. So with that, Lou, since you came off mic, I'd love for you to come back on and wrap up. Thank you, everybody.
Thanks, Jason. And just to sort of circle back on everything with our relationships with top manufacturers, being around for 100 years allows those partnerships to really be strong. And Panduit has been a supplier partner of ours for pretty much the entire history. But certainly with times changing, we've gone or grown from cable ties to industrial networking with Panduit, and we are pretty much full boat with Panduit. But based on this presentation, just wanted to make sure that I highlight that we have a team of experts that does work with Panduit for industrial networking, network assessment, documentation, management, anything that is needed with regards to the industrial floor and networking that goes on with it. There's a bullet point list there that you can see. And also the key part of this too is that the way the supply chain works is that we would be your first contact for any of the information that Jason presented. We'll work with their manufacturer's rep firm and then work with Panduit to get you exactly what you need. But certainly reach out to me or anybody at the Allentown team, or depending on where you guys are. If you are in the outskirts of the valley, you can see that we're in Reading and other places as well. But we would be your first call, and we would bring in the troops if necessary. But we do have specialists at FROM that could at least start the process with this whole sort of theme of industrial networking and where things go from there. So I don't know, is there another slide?
Yeah, just a thank you slide.
The thank you slide.
Yeah. So can I start? I just want to thank IFMA. I want to thank Mike for having Panduit. Lou, thank you for inviting us and organizing this. I really enjoyed the 2 presentations I did. Hopefully we can do more on more topics in the future. So again, thank you.
Well, we're gonna have a vote. We're gonna have a vote, Jason.
Was I good or not? Right.
That's right. And considering that it was you last time, and this time, I think you might have a good shot.